We turn now to the subject of the first derivative test for local extrema. If you recall, in the previous section, we'd covered the idea that local extrema, in other words, local mins or local maxes, can only occur at critical points. So in order to find potential places where local extrema occurred, we would find the expression for the derivative, set it to 0, and look for places where it was undefined. So if it was either undefined or 0 for a particular x value, then we would say that's a critical point and therefore is a candidate for being a local min or a local max. The problem is that that process didn't really give us a way to tell just from looking at the point whether it was a local min or a local max, or possibly neither, which was also an option. So the question is, how do we know that? The first derivative test will tell us whether something is a local min or local max or neither. So here's the first derivative test. The first derivative test says, suppose that x equals c is a critical point of f. Then there are three options. One is if f prime changes from positive to negative across x equals c, then x equals c is the location of a local max. On the other hand, if f prime changes from negative to positive across x equals c, then x equals c is the location of a local min. And if f prime doesn't change sign at all across x equals c, then x equals c is neither a local max nor a local min. I just want to draw for you why this makes sense. So let's suppose that I have a function that looks like this. What you can see is that in let's call that c. So what you can see is that over here, since the derivative is giving us the slope of the tangent line, if I draw in some tangent lines to the left of c, then what you can see is that the slope is positive. In other words, the slope is greater than 0. Then here's the critical number where clearly the tangent line is horizontal, so the derivative is 0. And then as I cross over to the other side of c, what you can see is that I'm getting negative tangent line slopes. So this is kind of the telltale sign of what a max looks like. Is the function is increasing as it approaches the critical point from its left, and then at the critical point, after the critical point to the right, it starts decreasing. Well, we now know that we can find increasing and decreasing by looking at the sign SIGN of the derivative. So if the derivative is positive to the left of c and negative to the right of c, what that means is that the function is going up and up and up. It rounds, to use the phrase of our former president, it rounds the corner, and then it heads back down. So that would indicate a max. On the other hand, if I draw it the other way, you can see that here. Let's suppose that I have I should have done that in purple. Let's suppose that I have a function that looks like that, where this is c. Now what we can see is that the derivative is the derivative would be negative because we have negative tangent line slopes, and then of course we have the horizontal. That gives us the critical point because the derivative is 0, and then as we cross over to the right of c, we see the derivative becomes positive again. So that's the situation that you see here, where the derivative is changing from negative to positive, and that's the telltale sign of a local min. You might wonder what this third case is about. What the third case really looks like is this. So let's suppose that I have a function that flattens out just momentarily, but then starts to go back up. So here, the derivative was positive heading into, in other words, let me just make clear what the critical number was. So here, we're going to call 0, that's going to be c. Coming from the left, approaching c, we're getting positive slopes that flatten out and eventually become a horizontal line at c, but then the function turns back around and starts to go up again. So we did get a derivative of 0 at c, but the function turned around and kept going up, so it didn't actually reach a max or a min. This is just sort of a false horizon. The critical number telling us we might have encountered a min or max there, but the first derivative test telling us that we didn't.